Something on your network stops working. Pages hang, a video call will not connect, but the lights on the box are all green. Before you blame the internet, look at your own laptop's connection. The box in the hallway is doing far more than passing packets along. It is a tiny computer running a tiny operating system, and it keeps several living tables in memory that all have hard limits. The first table is the NAT translation table. Every single outbound connection from every device in your home occupies one row in it, and that table has a fixed maximum size it cannot exceed. The second is the DHCP lease, the public address your provider loaned to the router. Leases expire, providers reassign them, and a router can end up arguing about an address it no longer owns. The third is the DNS cache inside the router. It remembers name lookups so they are instant next time, which is wonderful right up until one of those remembered answers turns out to be wrong. The fourth is the ARP table, which maps network addresses to actual hardware addresses on your local wire. One wrong row here and frames for a device disappear into nothing at all. Underneath all four sits the router's own memory. Cheap firmware leaks it slowly, and a wireless driver can wedge under sustained load, so the hardware itself gets tired over weeks of uptime. The reboot touches every one of those at once. Let us walk through what actually fails first, what the power cycle really erases, and why the relief you feel afterwards is only ever temporary. Take 1. Your laptop tries to open a brand new connection to a website. The request reaches the router in a millisecond, and then it simply sits there, timing out quietly with no error message at all. The router has to translate that connection. Your laptop's private address and port need mapping to the router's single public address and a free public port, and it writes that pairing into the NAT table. Except there is no free port left to hand out. A cheap router may hold only a few thousand translations, and a busy household with phones, laptops, and smart plugs burns through that surprisingly fast. Worse, most of those rows are already dead. A connection that closed badly leaves a half-open entry that lingers for minutes, sometimes hours, so the table stays full of connections nobody is actually using. Now the second table. Your router believes its public address is still 203.0.113.42, the one it was leased earlier today, and it keeps sending traffic out claiming that address belongs to it. But the lease quietly expired, and the provider reassigned that address to another customer. Replies now travel somewhere else entirely, so your connections leave the house and simply never come back to you. Table 3 explains the weirdest symptom of all. Some sites load perfectly while others refuse. The router's DNS cache is holding an answer, for example, "com that expired" or "that was wrong the moment it arrived." Your laptop asks the router for that name, the router answers instantly from its own cache, and your browser dutifully connects to an address where nothing is listening anymore, with no error to explain it. Table 4 is the ARP table on your local wire. It records which hardware address belongs to which network address, so frames know which physical device to reach inside your own home network. If a device changed address or two devices briefly claimed the same one, the stale row keeps pointing at a machine that is gone. Frames are sent perfectly well, and they simply vanish on the way. Beneath every table sits memory. Firmware leaks a little on each connection, buffers fill, and after weeks of uptime, the wireless driver can wedge entirely, so the radio stops answering while the lights stay green. Then you pull the power. Every one of those tables lived in volatile memory, so NAT, DHCP, DNS, and ARP all disappear together. The firmware restarts clean, and the radio driver initializes from scratch. On the way back up, the router requests a fresh lease, gets a current public address, and builds every table again from an empty page. Suddenly everything works, and it genuinely does look like magic. This is why the relief expires. Those tables refill at exactly the same speed as before, the leak resumes at the same rate, and in a few weeks you will be unplugging the very same box again. The real fix for a full translation table is a shorter NAT timeout. Dropping dead entries after 2 minutes instead of an hour keeps thousands of ghost rows from ever accumulating in the first place. The real fix for the leak is a firmware update. Vendors patch these constantly, and a router running 3-year-old firmware is carrying every single memory bug that has been fixed since it shipped. And the real fix for a tired, cheap router is fewer devices per box. 40 smart gadgets on hardware designed for 10 will exhaust something that no reboot can permanently repair for you. So the whole picture: a translation table that fills up, a lease that goes stale, a cached name that is wrong, an address row pointing nowhere, and firmware slowly leaking underneath all of them. That's how it runs. Next time the reboot fixes everything, you will know it cleared 4 specific tables rather than performing magic, and you will know which real fix makes it stop happening. Follow how it all runs. See you in the next one.